Okay, hello guys. Today our lesson is about arithmetic progression. Okay, so let's move into the first part about it. So we already know that for arithmetic progressions, that means like each term has the same differences, right? So we can say that the first term is called U1, and also we can use A to represent for this. Like we have 1, 3, 5, 7, 9, right? You can find the differences between each adjacent term is 2, right? So you can also code here's U1, U2, U3, U4, U5. And you can set here the first term also can be called as A, okay? And here you can find the common difference is 2, right? And each one is added with 2, added 2, added 2, right? And also you can call here the D to become the common difference, okay? So you can also set here U1 equals to A and U2 equals to A plus difference, right? And U3 equals to U2 plus a difference and also is A plus difference plus another difference, right? So that is A plus 2 difference. And also U4 can be considered as A plus 3 difference, okay? So continue to the nth term, you can set that is n plus n minus 1 times d, right? Because here we can find u3 equals to 2a plus 2d, right? Here are two difference, and here is the third term. And fourth term is plus 3d. So nth term has to add with n minus 1d, right? Okay, that is a nth terms equation, okay? So also we have the sum equations. So a lot of years ago, that Gauss, the very famous mathematics, right? So he has find a method to calculate the sum. So the problem is like he wants to calculate the sum from 1 to 100. Okay, so he trying to call this as Sn, means first nth term, or here we can also call as 100, right? Okay, so he just trying to rewritten down again like Sn equals to, so he first put 100 at the first time, first place, and the second is for 99, third is for 98, and then finally plus 1. So if you're trying to add the two sequences together, that is 2 times the sum, right? And here's 1 plus 100 is 101, and here's 2 plus 99 is 101, right? 3 plus 98 is also 101, right? And the last term added together is 100 plus 1, also 101, right? So you can say here 2Sn equals to 100, 101 plus together, right? So the value here is 101 times 100, right? So you can say Sn here equals to 101 times 100 over 2. So back from the arithmetic progression, you can say 101 here means the first term plus the last term, right? So you can say here is for A1 plus A100. And 100 means the number of terms, and 2 is a 2 series or 2 sequence, right? So now if you have like U1 plus U2 plus dot 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 to UN, so you can just try to rewritten the equation again. So that is the sum for the first n term, and the sum for the first n term can also be considered as UN plus UN minus 1 plus the U1, right? So you can just consider here 2Sn equals to U1 plus Un, and then times the nth term, right? So Sn can be considered as U1 plus Un over 2 times it, right? That is it. So based on the equation, you can also try to use A and D to represent it for the U1 and the Un, right? So we said U1 equals to A, right? So you can say here U1 equals to A, and also the UN equals to A plus N minus 1 times D, right? So here is UN. So you can just put it into it. So there's for N over 2 times 2A plus N minus 1D, right? Okay, that is for UN, okay? Okay, so just trying to solve the problems by using the equations. Let's just solve the problems together, okay? So the problem said that arithmetic progression, the first term is 5 and the difference is 3. So that means the second term is 8, right? The third term is 11. The fourth term is for 14, right? Okay, each term is bigger than 3 before the adjacent term, right? So it's at the 10th term, U10. So you can just using the formula, like U10 equals to A plus N minus 1D, right? So that is for A is 5, right? The first term plus 10 minus 1 times the difference is 3, right? So that is 5 plus 9 times 3 is for 27 plus 5 is for 32, right? Okay, so we can say here the U10 equals 32. And the second problem is the sum of the first 20 terms, right? So S20 you can just written down as the first term U1 plus last term U20, right? And then times the 20th term, right? So here, U1 can be considered as A, right? And U20 can be considered as A plus N minus 1D, right? So that is over 2 that times 20. So here, A here equals to 5, right? That is the first term. So 5 plus 5 plus 19 times the difference is 3 over 2 times 10, right? So you can just calculate the numerator's value. That is 5 plus 5 equals to 10, right? And 19 times 3 equals to 57. So the total value here is for 67 and then times 10 over 2. So here it can be considered as 335. So that is a final value for S20, okay? That is it. Okay, and another problem is to working backwards. So for Sn, we can set Sn equals to n plus a plus n minus 1d and over 2 times n, right? So if you want to just compare with already we have the term or the sum value, right? So we can set that is for 2a plus n minus 1d and over 2 times n, right? So you can just times them together as an plus n minus 1 times n over 2d, right? So you can just try to expand the equation, right? So that is for a plus d over 2n, right? And then, here is for d over 2n squared, right? And plus the a minus d over 2n, right? Okay, so you can calculate it as d over 2 equals here equals 1, right? 1 times n squared, so it's 1. And the second is a minus d over 2, that is for 4, right? So you can calculate a equals to 5 and d equals to 2, right? That is our final answer. So you can say the first term is 5 and the common difference is 2 in this problem. So just be very familiar with this. So you can also solve the problems with me together, okay? So that's for today's whole lesson. Hoping you can understand it for arithmetic progression and how to calculate the sum and the first term and the differences, okay? They are very important. So that's for today's lesson. See you next time. Bye.